Hi everyone, in this class we will look at how we can translate a Python script into a Revit macro. We will then see how we can add a Windows form to ask for a user input. And we will then take this code and paste into a Visual Studio template in order to create an external command. So why C#? Most of the examples online are written in C#. If you search for Revit API tutorials or examples, most of the time these examples are written in C#. So it will be good to have a general understanding of this language. The same language is used to build a zero-touch node and to build extension. So I think it's if you are not already familiar with these tools, it's good to have to start with something which is in between the Python and scripting and the zero touch and the extension, which is more advanced programming. Also, the code that you are writing is related only to the Revit API. It's independent from Dynamo, and it will be affected only by the changes in the Revit API. Then the last thing is the execution time. So not only because you don't have to open Dynamo or you don't have to search for the script through the Dynamo player, but Dynamo is something which is on top of Revit, and the speed of Dynamo is limited by this framework. And secondly, in Dynamo, you generally translate the Revit elements into, you wrap these elements into a Dynamo elements, and then you perform some actions. While if you write directly some codes into a macro, you will be forced to interact with Revit elements, and this will be the result will be that the execution time will be much faster. This is not a class on C#, so there are many fundamental C# concepts that we will not be discussed, and you will have to review the code and try to understand each statement, each passage on your own. There are plenty of tutorials online, and I will try to give you the topics that, as a beginners, you should be focused on. So there are three ways to extend Revit. There is the external command, external application, or a macro. External commands are commands that will appear in the add-ins external tools drop-down menu. External application are commands that appear directly in the toolbar, and macros are commands that can be run through the macro manager. There are two must-have tools when you are interacting with the Revit API. The first one is the Revit Lookup. So this allows you to snoop the current selection and to access all the elements properties and methods, and you can basically dig in and try and find very useful information and see how this information, where this information have been stored by the Revit software developer. The second tool is the add-in manager, which is a way to run your DLL libraries without having to restart Revit. This is important when you are working with Visual Studio outside the Revit environment. For what we will see today, so how to create a macro, you don't need that, because the macro will run automatically, and you don't need to quit and open Revit again. So how do we create a macro? If you go to the Manage toolbar and click on Macro Manager, this is the window that will appear. You have two tabs. The application tabs shows all the macro modules which are available to all open Revit projects, while the active document tab, which is related to the project in which we are in, so in this case this tab has the same name of the project that is open. If you are creating a macro in here, this macro will only be available to the project. So what I usually do is just I create a macro for that is available to all the Revit projects. So to create a macro, you need to first create a module, give it a name, and choose the language. This will open the Sharp Develop IDE, which is the layout in which we will write our macro. And as you can see, my first macro module has appeared, but we haven't created a macro yet. So there are two ways you can close these Sharp Develop and click on macro while you are selecting the module and call it Hello Revit. This will open again the Sharp Develop, and in here you will see that Revit has automatically created a method inside this class called Hello Revit, which is the name that we choose. And if you go back to the macro manager, you see that the macro now is visible in the my first macro module. Okay, so on your left you have the project organization. You can turn on and off the hidden files. Not. And at the moment we just have this C# file called this application. You have a properties panel on the right, and important, you have an output window at the bottom. The reason why you need an output window is because in order to run a macro, you need to build the solution. And building the solution will tell you if you the code that you have written is ready to be executed by Revit, or it has some errors and you need to solve before being able to use it. So when moving from Python to C#, the most important thing is that you need to declare the type of each variable or object that you are creating. For example, if I want to write a string, and in Python I could just have written message equal to hello Revit. In C# you need to declare what this message variable is. So you will start typing saying that it's a string, then you will give it a name, and then you will assign a value. And when you have done these 3 steps, you need to put a semicolon so that the C# interpreter understands that this is the end of the statement. And again, you can build a solution, and this is just a warning, it's not an error, and say, yeah, you have created this variable, but you have not using it yet. So what we can do, we can use the task dialog command to show a pop-up window. And the macro environment, the Sharp develop environment is super useful because it's whenever you are calling a method or a function, it tells you straight away what inputs you need, what arguments you need to define. So for example, if we just want to show a task dialog with a title called hello, and then it's a comma, and the main instruction is the message, then semicolon, and press F8. The bottom left it says that the build finished successfully, so you can go back, select the macro and run it, and this is the output. Also, you don't need to worry about indentation. You can do something like this and it's still valid. You need to be careful with double quotes or single quotes. So if you type single quote, that's specific for character. So if you are defining a string, you just need to use the double quotes. Okay, let's now have a look at how we can convert the Python script into a Revit macro. So this Python script, which was taken from a Demeter custom node and a little bit re-elaborated. What it does is, well, it imports all the Revit API namespaces. It accesses the current document, collects all the elements in the document that are not element types. It iterates through them, and if the element category is exists, so it's not empty, and the category name is equal to sheets, it appends this element into a list. It then iterates through these sheets, gets their ID, tries to delete them, and if it deletes them, it appends the ID and the deleted string into the results. If it fails, it appends failed, and this delete method is encapsulated into a transaction because we are changing the Revit document, and then it outputs the content of the result list. So first of all, we need to define our macro inside the my first macro module. So we can call it public void because we are not returning anything, delete sheets, then parentheses, which means that this is a method of this application class, curly brackets, enter, and automatically sharp developed places the closing curly brackets. It's, I think, good practice to just say that this is the end of delete sheets, and this is the end of class, and this is the end of namespace, because you will find quite easily that you may mess up with these parentheses, and it will be tricky to find which one refers to what. So the first few lines are already been created by sharp develop, and they are at the top, and instead of import keyword, C# uses using, and the library, so the namespace is the same, and you can find them in the references. We cannot access the document directly. We need to first of all access the UI document, and which is a property of this class, and is active UI document. And then we can access the document doc simply as a property of the UI document. So the UI document is quite important because it allows you to access the active view, for example, the document database, and the selection, so to retrieve all these currently selected elements in your project. We then need to define a collector. So collector is a filtered element collector, which is called collector, and need to say new filter element collector, and the constructor, it looks like something like this. So, and we can just do where element is not element type. So how do you know that this is the way of creating a collector? First of all, you should notice this new keyword that we have not used in the when we created a task dialog. So the difference is that task dialog has a static method, which is this public static task dialog result task dialog.show, which means that you can call this function without having to create an instance of that class, of that object. Filtered element collector instead does not have a static method. So if you want to use it, you need to first of all instantiate a new instance, a new object of that class, and then you can access their properties. It would have been the same as if we did task dialog td equal new task dialog title new hello, and then we would have set the properties. So I think it's called main instruction equal to hello again, and then task dialog dot show, just to call it. And if we compile, build the solution, and we go back macro, first of all, you see that we now have the second one that we just created. But if we run the hello Revit, this is the task dialog.show, and this one is the instance that we have created and we have run it. So these are the two ways of dealing with objects. After creating the collector, we need to create a sheet list. So a list in C# is defined by the keyword list, and also you need to define the type of the elements that will be stored in that list. If we are going to store elements, we need to type elements in these sheets. And again, because it's a list, you have to, it's not static, you have to create a new instance of that list element, and you will do it like this. Then the for loop in C# is represented by a for each, and if you press tab, automatically you will get a template of this loop. What we are going to loop through are elements. So for each element E in collector, if, and then parentheses, E dot category is the same, it's not equal to, instead of none, it's null, and instead of and is double E, and E dot category dot name is equal to sheath. How do you know that? You use the Revit lookup. close parenthesis, and then instead of the colon, you have the curly brackets. What are we gonna do? We are gonna append. It's not append. It's add the element E to our list. And then let's build. And luckily we didn't get any error. Then we need to start a transaction. So in C#, it's good practice to close the transaction into a using statement. So using parentheses transaction T equal again new transaction, and the transaction needs a document, which we have is our doc, and a string name. We can say delete all sheets. This will appear in the undo command. Close parenthesis, close the using parenthesis, open the curly brackets. Then start the transaction, t.start. It's a method. Why is a method? Because if you look at the icon, this purple box means that it's a method, and compared to this icon, which is a property. So when you have a property, you don't need the parentheses. And let's close it so we don't forget. And then what we are gonna do, in Python, we are saying for E in sheets, get the EID and then try and delete. So again, for each element E, or for each sheet in sheets, we were retrieving the ID. So element ID sheet ID is equal to sheet dot ID, which is a property, semicolon, and then try is again try is the same, but we need the curly brackets. Doc dot delete and a collection of elements ID or an element ID. So sheet ID. Instead of and then we were storing the results into a list. Now these are string, and then result new list of string result dot add sheet ID. If you want to convert into string, there is a method to do that, which is called string. Then to concatenate, we can still use the plus. And instead of except, it's called catch. Result dot add dot sheet ID dot to string plus failed. And then we are closing the transaction. Okay. Now, how do we, let's build finished successfully. We can go back to Revit. We have these sheets. So open the macro, delete, run, job done. If we want to notify the user that the action has been completed, we can show a task dialog, result, and then we want to show the result output. But if we do this, we will get an error which says that C# cannot convert a list of strings to a string. And if we look for a method you cannot extract one string. So you could probably do something like this. So means that you will get the first item, same as Python. But if we want to get the full list of elements, we can just have a string of result string, which is an empty string, and then we can loop to the string in result and append the value to that empty string with a break line, which you can define like this, or using environment dot new line. New lines. It's up to you. And then in here you can just type result string. Okay, so let's undo macro. Let's run, and these are the elements ID that have been deleted. So let's have a look at this code, and in particular, why did we need to check that the category is not null? So if we remove this piece of code and we build a solution, the solution works. And then if we go back to Revit and we run the macro, we get an error. So first of all, we can get more information out of that error if we use try and catch. So let's try to run these statements, and if it doesn't work, we can have catch the exception, and we can use a task dialog to represent that exception, and we need to convert into string. So if we build this solution, works. Let's go back and run. Okay, it tells us that the error is in line 63, and it's a little bit nicer than the previous one. And then again, this is the second task dialog, which is trying to give us the content of the result list, which is empty, and this is an empty string. So line 62 is, or 63 is this line, and if we want to get more information, because still it's not immediately to link the error to the fact that the element category did not exist, what we can do is to close sharp develop Go back to Macro Manager and click on Step Into. This will open the Sharp Develop in the debug mode, and you already see that he has already prepared a list of all our variables. And if we go to Step Into, we can go line by line and see what's happening into our code. So we are now in the loop, the element E. Okay, this is the first element, and if we click and we check, and we see that the category of this element is null. And why? Because it's a project phase information. And if we run again, we are now outside the for each, and we get into the catch. This is the error, and then the task dialog and the macro stops. So let's stop the debug and detach. And now we know why we need to check that the category has to be different from null. Now, this is not the smartest way of doing it, because it would have been easier, instead of selecting all the elements, to use another method, which is of class type of, and then just of class view sheet. So in this case, our collector will contain only the view sheet, and specifically we don't want the element types. So now if we run this again, okay, I need type of view sheet. Okay, so still running in the background now. Okay, run, and they are being deleted. So again, this is the preferred option, is just not to select all the elements, but just apply some rules directly to the collector to avoid having problems later in the code. Okay, so let's now try to tidy up a little bit this code that we have written. What we can do is to copy or cut these lines and store them into a separate file. So just right click, add new item. It's going to be a class, and let's call it helpers. And instead of having a public class, helpers is fine, but then the method is going to be a public static void, because we are not returning anything, delete elements. And in here, let's paste our code, so that in this application we try to minimize the amount of code, and we can just type helpers, delete elements, and then we will fix this later. Also, having them in a helpers means that we can make it more generic, and we can use it for other macros in this application, or in we can then copy and paste this code into our like helpers library. That's the output, the ultimate goal. So we need to pass some variables to this code. First of all, the document, because we want to make this independent from the document. So document will be an input. And as you can see, when I type document, C# doesn't give me any suggestion. That's because we have not imported the namespaces that contains the document, which are the Revit UI and the Revit DB. Also, if we try to run this code, to compile the code, see the namespace for list does not exist, because that namespace is included into the collection generic. So what else can we use as an input? For example, it would be good if we can define the type of elements that we want to delete. And we can have a type variable, type to delete, and use it here. Then we don't need to check for the category, because we are now selecting just the type that we want to delete. And in here we can say delete all type to delete dot toString. And let's compile. This code compiles and doesn't give us any error. We just need to fix this part, because now we need to provide a document and a type, which let's do the view schedule. And let's compile. So if we go back and run, these two schedules are being deleted, and we check, okay, this is the delete all, and this is the type. So ideally we should take the type to delete dot name and then toString. Also, instead of having to loop through the elements in the collector, we can, let's comment this, so control and forward slash. So in here we can just add a new method called toElements, and because we are now converting them to elements, the data type of the collector is going to be a list of elements, and in particular it's not list, but it's an I list, so a generic list of elements. So we can call this, we can get rid of this line, and for elements, let's say element E in collector. Now we need to be careful not to change all this stuff. E.id, this is AID, AID. So let's compile. It's working. So let's undo. So we now have both schedules and sheets. And in here we say copy this line and say, okay, type of view sheets, file, run, deleted, deleted, and in here delete all view sheets, delete all view schedule. So if you have noticed, the first time we run the command, we just deleted the two schedules, while when we run the last macro with when we converted the filtered element collector into elements, we got more than two element IDs that have been deleted. So if we snoop the database and we search for view schedule, we see that in the view schedules there are also the revision schedules. So, and they have same category. So if you want to make sure that you are not deleting the revision schedules, you need to perform an additional filter. Let's now add the Windows form to our application. So let's right click on the my first macro, add new item, form, and let's call it for delete. This will open a new tab, and this tab has a source and a design layout. If we go into design and we choose tools, we can start populating it with our components. So we will need two checkbox and two buttons, one for OK and the other one for cancel. We can resize, and the checkbox one, let's say, is called delete sheets, and let's change also the name which of the item. This the text is the displayed text, while the name is the name of the object. So checkbox sheets, and the other one is delete schedules and checkbox schedules. Let's then call button one OK, and we can assign also a behavior and a dialog result OK, which means it will close the Windows form. And for the button number 2, let's call it cancel, and let's give it dialog result cancel. And again, let's change the name, button OK and button cancel. Now let's go back to the source, and inside the class form, let's create two public booleans variables, which will store the check status of the two checkboxes that we have created. So the first one is gonna be schedules selected, and then the second one is gonna be sheets selected. We then want to associate the behavior of the OK button to collect the status of these two checkboxes, and we want associate this. We want to transmit the value of these two checkboxes when the user press the OK button. So to do that, we need to double click to the OK button, and this will create a button click event in our C# form. And in here, we can say the value of schedule selected is going to be equal to the checkbox schedules dot checked. And the value of sheets selected is going to be equal to checkbox sheets dot checked. So when the user will press OK, these two variables will be the value will be transmitted into these two variables. Okay, let's then go back to this application and let's create the code that will display the Windows form. First of all, we need to call the namespace for the Windows form. And in order to avoid confusion between the Revit namespace and the Windows form namespace, let's call this WinForms namespace. So when we want to call this one, we will need to use WinForm. So the code is going to be using variable form equal to new form delete for dot show dialog. This will show the dialog, and then if form dot dialog result is equal to winforms dot dialog result dot cancel, then we want to return. So we want to leave the Windows form, and let's test this. So let's run. We can select, deselect, and if we press cancel, it goes out, and if we press OK, it goes in. Still, it's not centered to the window, so we can go back and start position. Let's change it to center of the screen. Okay, so if the OK button is clicked, then we can we can pass this information into we can call either one or two or both our delete elements methods. So if form dot sheet selected is equal to true, then we want to delete the view sheets. And if the form dot schedule is equal to true, we want to delete the schedules. Let's build this code and let's see if it works. So let's delete sheets first, and these are deleted. Let's go back. Let's delete the schedules. and schedules, and as we have seen, the revision schedules have been deleted. Let's go back, and if we delete select both and press OK, the last thing that we can do is to add two labels displaying the number of sheets and the number of schedules selected. So let's leave the text empty and let's set the name to label sheets and label schedules. So how can we assign a value to these labels? One way is to use the check box sheets checked changed. So when the user tick these boxes, the label will appear. And in order to automatically create this code, we just need to double click on the checkbox. We can have two integer storing the number of sheets and the number of schedules, and we can assign a value to these two variables from this application. So in this case, label sheets dot text is going to be equal to sheets count dot string, and the label schedules dot text is going to be equal to schedules count dot toString. Okay, we then need to go back to this application, and before displaying the form, we need to assign a value to this sheet to sheets count and schedule count. So in here, if we type form dot sheets count and form dot schedules count, we can basically select all the sheets and count them. In the helpers class, we can have a class. So let's do close, delete methods, close class, close namespace. Here we can have a new public. This time we want to return public static, because again, we want to be able to call it directly, and we want to return an integer. And we can call it count elements. And what this helpers will do, it will basically take these items and count them. And because it's a count, it's going to be an integer. Let's call it count, and then return count. And what we need to have as input is the document doc and the type, instead of to delete, to count. So if we go back to this application, form.sheets.count is going to be helpers dot count elements doc, and the type is going to be view sheet, and the other one is going to be the view schedules. Let's compile. Helpers, we forgot colon, and we need to say type of, and then let's run it again, and now it seems to work. So if we run this code, 8, 10, but when we untick boxes, they don't disappear. So let's go back and try to fix this code. So let's go back into in here, and then first of all we can add some more information, like selected 8 worksheets selected and schedules selected, and we can run an if. We can add an if statement. So if the checkbox schedules dot checked is equal to true, then I want the text to be like this. Instead, the label schedules dot text should be equal to 0 schedules selected. And we can do the same for the sheets. Checkbox sheets dot checked is equal to true, else label sheets is equal to 0 sheets selected. And then again, this has to be the text. And let's run. So 8 sheets, 0 sheets, 10, and 0. And we click. So we need to fix the layout or the width of this label, but also maybe just want to display 0 automatically instead of having something like this. But it's, or we can just get rid of this directly, but it's something we can fix. The last step is going to be to convert our macro into an external command. So let's start Visual Studio and let's create a new project using the Revit 2018 or 2019 add-in, and let's call it delete element. So the structure of this file has an app, external application, and a command file, which is where we will need to write our copy, our code. So let's start removing this code, and let's keep the UI application, UI document. Also there is an add-in manifest which will be automatically copied into the Revit folder, add-in folder, as a post-build event. So let's go back to our macro and let's take this code inside the method and copy it into the command. We can remove the UI document, which is not valid anymore, and it's going to be replaced by this UI document, UI application. Then we need to add the helpers. So let's call it helpers class, and then let's go back and take everything inside the class, and also let's take the namespaces, which will solve some of the errors. Let's go back to the commands. Again, WinForms. Let's take this one and let's add it to the namespace, and also we need to add it to the references, and we need to add system forms and also system dot drawings. So both of them need to be added, and let's make sure that copy to local is false. The return should be return result dot cancelled if the dialog result cancel is true, and then we need to add the WinForm. We could recreate from scratch, but it would take time. So if we right click on my first macro and then open the folder in Explorer, we can take this file path and add this item as an existing item to our solution. So if we navigate into that folder, we can take form delete.cs and add that to the solution. There are some tweaks to do to this file. First of all, we need to so in order to access the code, we can press F7. The namespace is different, so we need to change it to the one that we have used in here, which is delete elements. Or you can just call the Visual Studio file with the same name. And also, instead of if you right click and do rename, it will rename this in wherever it appears, which is here, and then it's in here form delete designers, which is the structure of our dialog form, WinForm. Okay, so this is it. Let's go to build and build a solution. Okay, so succeed, and the add-in is being copied into the add-ins folder, and if we load that, we can let's go back, access it from the external tool, command delete elements, and run it, and it will be available.